Good morning, guys. We are going to look at a game today that I usually do in class for chemical and physical changes. And it's on a PowerPoint. And I think that the information on here is still good. And so I'm going to try to go over it with you in this format. I know that it would be way better if it were done face to face, but we're left with what we have here. So we are going to try to do it this way, and let's see how it goes. So what I have is you need to decide if this is a chemical or physical change. And you need to be able to give me evidence to support what you say. Okay, that's the deal. And I've tried to pick out some things that are a little bit, might be iffy or a little tricky, so that you will learn some more information as we go along with that too. Okay, so first off, we have the example of aluminum foil, and we have aluminum foil crumpled up. Is that a chemical or a physical change? It would be a physical change because it's still aluminum foil. The evidence is your original substance did not change what it was or what it is, okay? It is exactly the same thing. It's just changed its form, shape, texture, whatever. Okay, example number 2 is bread and toast. Might be considered a little bit of a tricky one. This is a chemical change. And let me just say, I add this one because it is tricky. Generally, when you add heat to a system, whatever it might be, you are going to have a chemical change happen. Okay? Not always, but in general, and this is an example. You can't get, your evidence is you can't get your bread back. Okay? It's changed what it is. And if you want it to go a little bit further, it changed color, which would be some evidence that there's been a chemical change. And it may have a change in odor. And you let it go long enough, it will be a little burned. Okay, so that is a chemical change. Number 3, we have a lump of clay and we have a clay vase. Now, you have to listen to what I say and not look exactly at the pictures because I was limited by the pictures that I could find for this. Okay, so we're just talking about a clay vase. The example here, a lump of clay to a clay vase, would be a physical change. I could then take that lump of clay that I've turned into a clay vase and I could turn it into a sculpture of somebody's head. Or I could turn it into a bowl or whatever. Now, if I would have said a lump of clay and then into a ceramic vase, which is what the picture is of, that would be a chemical change because we've added heat and the substance is totally different. We have a new substance. If I take a lump of clay, a bunch of clay, and just throw it on the table, it just whops on the table. If I would take that, a ceramic vase and throw it on the table, it would shatter into a million pieces. The substance has changed. You have a new substance. Okay, but if you're just talking about a lump of clay turned into a clay vase, that is a physical change. How about milk and then sour milk? And you can't see this very well, so I'm going to try to go a little bit closer for this one. Oh, you still can't. Well, there you can see it a little bit. I picked that picture because you can see the picture of the funky odor coming out of the milk. That's why I picked that one. Milk to sour milk. that would be an example of a chemical change. And your evidence would be that it is not the same substance that you started with. It probably has chunks in it. There is a change in odor. There may be a change in color. Don't know. Depends on how long it's been there, I guess. But that would be an example of a chemical change. Here we have tarnished jewelry and clean jewelry. Now this is a little bit of a tricky one too. Partly because of the verbiage that we use to describe it. Tarnished jewelry to clean jewelry is actually a chemical change. The tarnish on the jewelry is silver sulfide, I believe. It's a totally different new substance. It's kind of like rust on iron. That rust is the iron turned into iron oxide, which we call rust. Same thing with tarnish. That is silver sulfide. Now, when we clean it, that is just the verbiage that we use. It's not, we're not really cleaning it. We're changing that silver sulfide back to silver. Okay, so that one I threw in there so that you would understand that with like rust and tarnish and whatever. Okay, here's hydrogen peroxide, and here it is added to a cut. So that would be a chemical change, and our evidence would be that you see bubbling, fizzing, foaming. Okay, on an open cut, that's what will happen. Because your hydrogen peroxide is actually toxic to human cells. So your body has an enzyme called catalase in it that will break it down so that it turns into water and hydrogen, I believe, so that it doesn't hurt your cells. And that's the foaming, fizzing, bubbling that you see. Okay, how about butter melting in a skillet? Butter melting in a skillet. That is an example of a physical change. It's still butter. Remember, a state of matter is a physical change. All right, now if we left it in there too long and it burned, then it would be a chemical change. And the evidence to that would be a change in color, a change in odor, a change in taste, those kinds of things. But at this point in time, if we're just melting it, it is a physical change. Fireworks and a fireworks display. This one will be easy. This is your classic example of a chemical change in my mind. You have a change in color, odor, a change in odor. You have the production of light, heat, sound. It hits a lot of the hints for a chemical change. Okay, again, you're going to have to pretend the popsicles are the same kind of popsicle. Couldn't find pictures of that. But a liquid popsicle to a frozen popsicle is basically what I'm saying there. And it is a physical change because it is only a change of state. State of matter changes are physical changes. And here again we have... the evidence would be that it's still the popsicle, whatever it is that's making up the popsicle, the flavoring and the water and whatever. Okay? How about gasoline and burning gasoline? That is going to be a chemical change. Our evidence is that we have a new substance. What we started with is not what we end with. There's probably a production of sound. There's a production of heat and light. Anytime anything you add heat energy, it's probably, you add enough heat energy, I should say. If you burn something, it's going to be a chemical change. Here, water evaporating from a lake. The key word is evaporating. That is just a change of state, so that is a physical change. Frying an egg would be a chemical change. What you start with is not what you end with. We still call it an egg, but it is something different. And we've added heat energy. Okay. Lighting a match or a fire, again, burning would be a chemical change. There's a production of heat, light. There may be a production of sound, especially with the logs crackling there in the fireplace. Leaves changing color in the fall. This one again is a little bit tricky, which is why I added it. And the picture there on the left is an oak, and the one on the right is a maple leaf. So pretend they're the same. I couldn't find two pictures the same, of the same species. So that's, just pretend that's not what we're looking at. We're just talking about leaves changing color. That is actually a chemical change. Okay, there are, and that one is a little bit tricky, but the evidence would be that there is a change in color. Okay, at this point, since we're not face-to-face, I think I'm going to leave it at that. But just know that that one is a chemical change, and your evidence is that the leaves have changed color. Next one is baking a cake. That is a chemical change. You know, pick one of your ingredients, like eggs. Can you get the eggs back? No. Can you get your flour or your sugar back? No. You've created a whole new substance at the end, and you've also added heat to it. So that would be a chemical change. Spoiled food. The one on the picture on the left there is toast with mold growing on it. It's kind of hard to tell in that picture. And then we have strawberries with fungus growing on it. Spoiled food is actually a chemical change. Those fungi, what you see are actually just the reproductive parts. The body of the fungus is inside the bread or inside the strawberries, and it is actually decomposing it as a food source. What you see on the outside are the reproductive structures. Okay, so those are actually, this is not very scientific, but for us, basically what's happening is that fungus, those molds, in this case, are eating those food sources. Okay, they're decomposing them. Paper shredding. Paper is shredded. That is a physical change. It is still paper. You do not have a new substance at the end of it. We've changed its size, shape, you know, but we've not changed what it is. How about sugar dissolving in water? And the key word there would be dissolving. That is a physical change. Remember, solubility, when we're talking about dissolving, is nothing more than a physical change. You can get your sugar back, you can get your water back. It tastes like sugar, okay? Nothing more than being dissolved in it. But what happens if we take that sugar, dissolve it in water, and then heat it? That is actually a chemical change. That is how you make caramel. I'm always surprised that people don't know that when we talk about it in class. That is a chemical change, because what you start with is not what you end with. You have a whole new substance, and you've added heat energy to it. A different odor, and again, these were hard to do pictures of, but a skunk, and we have a rotten egg there on the right. The skunk doesn't always smell like the skunk smell that we think of. That is a defense mechanism for him. And so it is a different odor. The egg that you have in your refrigerator right now smells very differently than what a rotten egg would be. You know, say Easter's coming up, you didn't quite find them all in the yard. So July rolls around and you smell something and go look and you find an Easter egg left over from April. It is going to smell totally different than what it did originally. It's going to have quite the sulfur smell, and that is going to tell you that it was a chemical change. Okay? And the last one. This one is a precipitate. That one is in your notes. And I told you that you would, I think there was some video that you looked at too. But there are two clear liquids, and as soon as you mix them together with the top two pictures, you get a yellow precipitate. The one at the bottom is a brown precipitate, but you can at least, I like the picture in the front because, or at the bottom, because you can at least see the brown in the bottom of the test tube. Okay? That is a chemical change because we have the production of a solid. So hopefully this helped you a little bit and gave you some visuals of what physical and chemical changes look like.